All right, so question 6. What I find about these problems is like people struggle knowing where to start. Okay, once you find the starting point, then you get the ball rolling, and it maybe isn't as difficult. But obviously, you can't start, can't finish. Um, you get two triangles there, right? Okay, so I'm going to give you an idea of, and every question is a little bit different, and even the questions that we're going to see in other sections and other areas of geometry as we finish the year, the directions are going to tell you, hey, start in the blue triangle, or start in the green triangle, or start in this figure, or start looking at this side. So it can give you the whole thing, and you got to decipher. It's kind of I view them as kind of like riddles or puzzles. Okay. I think the best suggestion is to look at the separate shapes and ask the question, which one do I know more information about? You know more about the blue one or the green one? You know more about the green one. And the blue one, everything is unknown, right? All distances are variable. In the green one, you know the hypotenuse, right? So that's where I'm going to start. Okay, so I'm going to start over there. And as you go through this, I would not try to force myself to say that I got to find A first, and then I got to find B, and then come back and find C, and then find D. Work inside the problem as if there is no math Excel attached to it, and you have to find all of those side links, and they're not in any particular order. Does that make sense? Find them all first, and then go back to math Excel. So, okay, I've got this list of answers. Type them in appropriately. Okay. I think a lot of times they try to do it. They try to label things so that if they are alphabetical, that is the first thing you find, and then the B is the second thing that you find. But that's not always the case. Okay, so just keep that in mind. So if I look at this triangle here on the left, is it 45, 45, 90? So if I put my template of a 45, 45, 90 on top of it, remember this is in radical 2, and a 45, 45, 90, right? If I put that on top, maybe, if I overlap that, what distances overlap? In radical 2 and 19 radical 2. Okay? So that right there is going to generate my equation. N radical 2 equals 19 radical 2. So from that, what does N have to be? N has to be 19. Okay? Well, N in my template is that segment right there, which if I overlap my template with the green triangle, ends up being C, right? And N also is that segment there in my template, which overlapping my triangle ends up being that segment there. Does that make sense? Okay, so we've solved the first portion of the puzzle, and it has gotten us a new clue for the triangle on the right. The triangle on the right is now a 30, 60, 90, right? So across from a 30-degree angle in a 30, 60, 90 is always N, correct? Okay. Now just make sure that you understand what we're doing here. When I come into the second triangle, this N may be different than the N that was over here. Does that make sense? Okay, for this problem it's not. They're the same thing. But it might make sense to call this like W. Okay? And then this be 2W, and this be W radical 3. Okay? Because what I think people do is they say, well, N over here was 19. So then they're going to come over here to a 30, 60, 90. If this was a 30-degree angle up here, and this was 60, this would be N right there. And they say, oh, that's got to be 19 because it was N over here. But it's not 19. Does that make sense? Okay? So this is ultimately starting a brand new problem with a new dimension here of 19. So then if I take 19, what does 2W have to be? 38. So that was the B segment, right? And what would this segment down here be if W was 19? 19 radical 3, so that would be D. I want to show one that kind of explains what I meant there by that idea that N could be different. So let's say this is a 45, 90. Let's say this angle up here is 30, so it might be more like that. So say that's 30 degrees, and this would be 60 degrees. Let's say that this is 14 radical 2, and our goal is to find, I just want to find X and Y. Okay? If I put my template on top of the triangle on the left, that means that's n radical 2, right? So those two things are going to match up because of 45, 45, 90, correct? Is that okay with everybody? So what's n going to be there? 14. Okay? So in my triangle here on the left, I have that segment, the leg of the right triangle, to be 14. We're calling that n. Okay? This segment right here, in the 30, 60, 90, that's usually what we call n in a 30, 60, 90. I want to go through this and see if we get the same 14 that was in the blue triangle. Does that make sense? And that should tell us that maybe they're not always the same value. So right now, if I look at this 30, 60, 90, this is 60 degrees, which across from 60 is your n radical 3 side. So if I overlay these two triangles, okay, doesn't the n radical 3 land on the 14? Make sense? So n in the blue triangle was 14, but n radical 3 in this white triangle is the 14. I'm going to say n radical 3 equals 14. Divide both sides by radical 3. That is the n side in the 30, 60, 90, and that is going to be this side right here. It's across from 30. So that is what Y is. Okay? So in the template, for the 45, 45, this is 90, or 45, 45, 90, this is N. In the 30, 60, 90, this is N. But when I find N here, it's not the same as the N there. Is that okay with everybody? So it might make sense as you see these two triangles, a 30, 60, 90, or 45, 45, 90, or it could be two 45, 45, 90s, or two 30, 60, 90s attached to one another. Maybe you don't want to use N all the time. Maybe use N and M. Maybe use N and W or whatever for, so you don't get yourself confused. All right? But if you keep it straight, that's fine. Straight. If I double that, I get 28 radical 3 over 3 to give me my hypotenuse. What would this distance right here be? That'd be 14 as well. Is that all right? Any other questions on that? Well, there's going to be a chapter eventually that talks about areas, and we're going to be interested in finding areas of shapes, such as this trapezoid, and what they do, and it's just, like it's intentional. When we get into the area chapter, a lot of your distances that they provide you, so So if I'm in like seventh grade math class, and we're talking about areas, okay, and I want to find the area of a triangle, or I want to find the area of a trapezoid, or maybe doing surface area or volume or something like that, they will give you all the values you need, and then you just put them into the formula, right? Because at that stage, seventh grade, that's what we're working on. Can we substitute? Can we use the correct formula? That kind of thing. When we get to high school, we start talking about the same exact formulas, the same exact area formula, same shapes. They will take away distances. They won't give them to you directly. They will hide them. And when they hide them, they'll use things like special right triangles to hide them. Okay? So there will be eventually a chapter in which we come back and find the areas. I know we're not trying to find the area right now, but we will find the area of trapezoids like this. But in order to do that, the only way we'll be able to navigate that section will be to understand what 30, 69 triangles, 45, 45, 9 triangles yield for us. Okay? So what I'm trying to get at, if we struggle with this and we have the mindset that it's just one section, I'm going to get, time will pass, we'll get through it, and then I can forget it and not worry about it. That will not happen. You will not be alleviated in regards to these special right triangles for probably about 3 more years, okay? Because they're going to continue to pop up in other areas of your coursework. So they want A and B. So this is a trapezoid. Okay, this angle here and that angle there are right angles, so that makes this segment parallel to that one. Okay, everybody? Okay. Now I know we don't see a triangle right now. Okay, but if I come to this vertex right there, how many segments go from a point, not on a line, to that line? Okay, so I'm going to say this, like that's A, B. Let's call that point A, B. This is, let's say, that's point C, and that's point C. So I'm just drawing this picture again without all the other parts to it. How many lines go from C perpendicular over here to AB? We know one. We know we had a postulate that said from every point not on a line, there is one and only one line that is perpendicular to the given line. So do you guys agree that from C, there is a line that goes perpendicular to that opposite side? Does that make sense? Okay. So if that's the case, what did we just create? Okay, we've got this triangle. You said square, maybe, but it's bare minimum, it's a rectangle right here. Okay, but we got this 30, 60, 90 triangle now, right? Okay. Now what's nice about this is I don't know, and this is, I think they ask you to find the length of A first, and that's where people would maybe get stuck. Like, how do I find A if I don't know anything about this triangle right now, correct? Okay. You actually have to find B first. Okay. And what Jagger said is how we're going to get there. If I have 3 right angles, okay, that means this segment there is now parallel to that one, right? We got parallelogram with 3 right angles. This thing becomes a rectangle, right? If that's a rectangle, how big is that distance right there? It's the same as 6 radical 3, right? Opposite sides of a rectangle or opposite sides of a parallelogram are congruent. So that's 6 radical 3. Okay. Now, B, I don't know that. Okay, but it's going to be what compared to 9? Is it? 9 is that whole thing. So it's less than 9, but I don't know. So what we're going to do is we're going to take this template. This is my n radical 3 side, right? This is my n side. And this is our 2 inside. If I lay that on top of this triangle, what overlaps? N radical 3 and 6 radical 3, right? So what's n? and a 6. Now, look back at your triangle then. You see where n should go now? Isn't this little distance right here that n? So that's 6. So how big would that distance be? 3. So how big is b? 3. Okay. Now I always get people say, "Well, that can't be right. That 3 is smaller than that 6." They do that intentionally. Okay. They want, because looks can be deceiving, so they will distort things distance-wise to confuse you, because they want to make sure that you're not answering questions based on the way it looks. They want you to make sure you're answering questions based on the geometry and the algebra. That kind of makes sense? Okay. Just kind of getting us back to what I said at the beginning. Eventually, I'll give you this formula. Area is 1/2 h b1 plus b2. That's the area formula for a trapezoid. H is going to be the 6 radical 3. Okay. B1 is going to be that 9, base 1. And B2 is going to be that 3. But the only way that I could find that B2 was through this special right triangle work, correct? So no way to find the area unless you find B2, only find B2 through a special right triangle. So that'll be kind of what we talked about in chapter, I think, 10. Yes, 36 triangle 3. How'd I get B? Because that segment right there is the same as that segment there, right? And this segment is 9, right? And that one is 6. So 9 minus 6 will give me that 3. Anything else? All right, so this is so they give you some pictures here that I think confuse people on this question. Don't let the picture confuse you. You guys ever heard of like a speed square and construction? That's what we've got here. It says the triangle is in the shape of a 30, 60, 90 right triangle. If the hypotenuse of the outer triangle is 31 feet, find the length of the legs of the triangle in inches. Okay. So basically the way we read that is telling me that triangle makes no use to me, or is of no use to me. So it's just there to be there, I guess. So if I'm at 30, 60, 90, isn't a 30, 60, 90 across from 30 is always the inside. Across from 60 is always the n radical 3. And across from 90 is always the 2n, right? So in this triangle, that is the only one that I can make the equation with. So say 2n is equal to 31. So n is 31 over 2. Now it says simplify your answers, type an integer or a simplified fraction. Type exact answers using radicals as needed. So this does equal 15.5. Okay? But it's 15.5 a fraction. No. Okay? So I'm going to keep things, if I'm going to enter in, I have to keep it as 31 halves. So this side becomes 31 over 2. This side becomes 31 over 2 times radical 3. Something that I think in the past has also presented people problems. I can write 31 over 2 times radical 3 like that. It's the same thing as taking 31 radical 3 all over 2. Those are equivalent. Okay? And they're equivalent because this radical 3 has a denominator of 1. We're going to multiply these. Does it go top times top, give me this? And bottom times bottom will give me that. So those are equivalent. So you can write the 31 halves out in front, and then that radical 3. So this 31 halves kind of looks like a coefficient for the radical 3, written that way. Or maybe the 31 looks like the coefficient for 3 here, or however you want to think about that. Does that help with that question? No, it asks for your answer. Oh, okay. I didn't pay attention to that. I'm sorry. Okay, so this is in. So now this. So I did everything in feet, right? Okay, so this is feet. So how do I go from feet to inches? Times by 12. Okay, so I'm going to take 31 radical 3 over 2, multiply by 12. Before I start multiplying here, does that 12 cancel with the 2 here? It gives me 6, right? Okay. So now I'm going to take 31 times this 6. So it gives me 186. And then times my radical 3. So that's what this side would be, 186 radical 3. This side would be just the 186. And obviously they don't want that other stuff. Does that help? Anything? 14? All right, so first part of this question says, part A says, how long is the longer brace? So, and then the second question they ask will be, how much higher does the longer brace reach than the shorter brace? All right. Scenario says heavy winds damaged a house. Workers placed a 6-meter brace against the house at a 45-degree angle. Okay. So over here is your house, right? Are we okay with the image here? Try to keep this wall from maybe falling down, whatever. So then at the same spot on the ground, they placed a second longer brace to make a 30-degree angle up here. Okay. Let's complete the parts below. So they want to know how long is this longer brace. Okay. Can you guys see that there's 3 triangles at play here? Okay. We've got this overall triangle, correct? Okay. We've got that triangle right there, correct? And now we've got this triangle here that is just yellow. This little, do it this way. You get that triangle there with the red hash there. Okay. What we'll find out later on when we get to laws of sines and laws of cosines in this class, that this question can be asked or answered looking at just that yellow triangle with the red hashes through it, instead of looking at the triangles that we're going to focus on right now. Okay. But right now, based off of what we know, let's just look at that green triangle. What kind of triangle is that green triangle? 45, 45, 90. So if it's a 45, 45, 90, the n radical 2 side for a 45, 45, 90 is the hypotenuse, and this is n, and this is n, right? If I put those on top of, put that on top of this green one, what equation do you generate that's going to allow you to solve for n? Okay, so for mine it's 6. Okay, so I'm going to say n radical 2 is equal to 6. So then n will equal 6 divided by radical 2. We'll rationalize that. And n becomes 3 radical 2. Is that okay? Would you guys agree that n in my green triangle is the legs? So it's that distance right there. And it's that distance right there. Those are both 3 radical 2. Is that all right? Okay. Now, let's look at let's now just look at that triangle. Because that's the one with the longer brace, right? This segment here is the longer brace. That's the one they're asking about throughout the entire question. If we look at this triangle, is that a 30, 60, 90 triangle now? And that's 30. Okay. Now, in my 30, 60, 90, let's just say that this is, I'm going to call it K instead of N. Doesn't matter. So if I put these on top of each other, doesn't the K side match up with the 3 radical 2 now? Okay. So I'm going to say that K equals 3 radical 2. So then this side right here in our template would be K radical 3, right? That's across from 30. And this would be 2K. So coming up to my picture, I'm going to do the 2K first. This would be this distance right there. The distance right there is going to be twice as big as that. So you guys agree that's 6 radical 2? That make sense? Okay. Now, this distance right there is going to be K times our radical 3. So that's going to be, so if I take 3 radical 2 times radical 3, that becomes 3 radical 6. 3 radical 2 times radical 3. Multiply the radicands, you get radical 6. Multiply the coefficients, you get 3. So 3 radical 6. Is that all right? So it says, how long is the longer brace? That would be our 6 radical 2. They ask it in a nearest tenth, so you can use a calculator to make that a little bit easier on yourself. The next question is, how much higher does the longer brace reach than the shorter brace? When I ask that question, how much higher does it reach? It's asking for that purple distance right there. Okay? So what would I do with that number right there and that number right there to find that purple? Subtract them. 3 radical 6 minus 3 radical 2. And this answer right here is, in my opinion, the reason why they're asking you to type things in a decimal rather than the tenth place. If they ask you the exact value, can you simplify that? You remember how I added subtract radicals? remember, say again? No. In order to add or subtract radicals, those numbers have to be the same. Okay? And the reason for that is think about this. If I took this is the algebra that I think you guys obviously you're taught algebra and algebra 1 and state has these standards and all that kind of stuff the curriculum we're supposed to teach. But I think that you don't get this type of instruction that I think is very beneficial for understanding my rules of why we can't add these together or subtract these. If I had 3 times 4 minus 5 times 4. Okay? Can I rewrite that as negative 2 times 4? That makes sense? And we can do that because think about 3 times 4 means 4 plus 4. Actually, let's do the 3 times. We'll do the 4s. So 4 plus 4 plus 4, right? Okay. The 5 times 4 means 4 plus 4 plus 4 plus 4 plus 4, right? Now, because it's minus, these all become minus signs, right? So now it's 4 plus 4 plus 4 minus 4 minus 4 minus 4 minus 4 minus 4, right? Can you link that there with that one and say they're opposites? Is that one there and that one there opposites? Is that one there and that one there opposites? So those all cancel each other out, right? And what are you left with? 2 negative 4s, right? And you can take that negative 4 because the multiplication is commutative, associative, all that kind of stuff. I take that negative and write it that way. Does that make sense? Okay. Well, when we look at this here, 3 radical 6 and 3 radical 2, think about what radical 6 is. It's a symbol for another number. And that other number is, I'm just trying to evaluate this quick. So square root of 6 is that. Square root of 3 is that. So when we ask this question, I guess square root of 2 is what we want. When we have this question, we're actually asking, you have 3 times the 2.45 number. Okay, that is the 3 times radical 6. Does that make sense? Okay. And then minus 3 times the radical 2, which is the 1.41 number. Okay. If I break this down algebraically, what this means is I got 2.45 plus 2.45 plus 2.45 minus 1.41 minus 1.41 minus 1.41. Does that comparison kind of make sense to what we did earlier? Or is that opposite of anything over here? So they don't cancel each other out, which means they can't combine as like terms. Does that make sense? Okay. So this here is already fully simplified. That's how we would leave that in radical form because you cannot add or subtract those things. Okay. And remember that it's also this way. You can think about it this way. So radical 6 is a symbol, correct? What are other things that we have talked about in this class in Algebra 1 that are symbols? Starts with a V. Say again? Variables. Variables are symbols for numbers that we don't know, right? Do you know off the top of your head what radical 6 is? Because it's a symbol for another number, right? Until I use my calculator, I don't know what that number is. So let's assume it's unknown. So let's say radical 6 is an unknown value. And let's say radical 2. If you didn't know radical 6, you probably don't know radical 2 off the top of your head. So to you, it is also unknown. Can you do that? Can you take 3x minus 3y? No, because they're different variables, right? And the reason for that is because if I take a 3 out, I don't know what x minus y is. Okay? But if they were like terms, let's go, it's like 3x minus 7x. The reason there that I can combine like terms is because I can take an x out, and it becomes 3 minus 7. And you can do that work. That's negative 4 times the x that's out there, so negative 4x. But you can't do that here when they're unlike variables. So this is viewed as kind of an unlike variable to that. So it's already simplified. That, I think, is the reason why they let you round it to the nearest tenths or tenths place. So we don't have that issue to talk about. Okay? Any others? Radical work is a nasty kind of world. Would you agree with that? Okay. If I told my baseball players this yesterday, we were doing some calisthenics, okay, some exercises, and for some of them it was hard. Okay. So they were dogging a little bit. If you always dog it, is it always going to be hard? Are you always going to be out of shape if you always dog the exercises? Yeah. So if I dog the work with radicals, they're always going to be hard. Okay. But if I go home and I spend some extra time on this outside of the ones that I teach in class, it's going to make it easier. Okay. So I come a bit, I go home, get on the treadmill, run a couple miles every night, every week, something like that. It's going to make those exercises during practice so much easier to get through. So it's the same kind of thing. They're only going to get easier if you force yourself to work with. And just like anything like baseball, if I'm not very good at hitting curveballs, okay, I'm not going to get enough curveballs in practice to be successful in a game. Okay, you're not going to see enough radicals in class to be successful on a test or a quiz with them. Okay, you got to go home and get in the backyard and have somebody throw curveballs at you and take batting practice day after practice and do extra things, right? Same idea in the classroom. Okay. Any other questions? I'm going to let you guys use the remaining time. That clock's about 5 minutes slow. Remaining time, you have 13, 14 minutes here to finish up that assignment. Keep working on it. On Monday, we're going to continue with this stuff. We're going to keep working with 30, 60, 90, 45, 45, 90, trying to refine those skills because of how much they're used beyond this, okay? Just to give you insight, some of you are probably going to take college algebra, trigonometry. My trig students start on Monday talking about special right triangles in great detail, but let me go up to the notes that we had. See if we can find them. I'm not sure where they went. Here's some stuff. In trig, we deal with sine, cosine, and tangent. And we'll talk about that here in a few weeks with you guys as well. But notice some of the key degrees that are listed. 30 degrees, 45 degrees, 60 degrees, 90 degrees. Okay? And we're going to be very interested in all of these things that come over here. Okay, all these values in these last three columns are from 30, 60, 90 triangles. Okay, so the better you understand them now, the easier those courses that are going to use them later will become. You can take physics. Physics uses 30, 60, 90 triangles quite a bit. What sucks there, though, is that it doesn't really teach you that prerequisite math, because he's assuming that you've seen geometry, you know what 30, 60, 90s are, and you can use them, apply them when you need to. So you want to keep your eyes open for those. I don't